Prevention-based tools leave you blind to threats inside your network. By adding network traffic analysis to your SOC, you can find and stop attackers before they make their move. ExtraHop provides complete visibility at enterprise scale. Detect threats 95% faster with machine learning that helps Tier 1 analysts perform like seasoned threat hunters. Visit extrahop.com/Security Weekly to learn why the SANS Institute calls ExtraHop fast and amazingly thorough. That's extrahop.com/Security Weekly. Networks are becoming increasingly complex and fragmented, and digital transformation and DevOps are driving an explosion in network connectivity changes. With each new network connection, cyber attackers may gain another opening to breach or traverse the network. At 2FIN, they've pioneered a policy-based approach to network security management using automation and analytics. As a result, you can make network changes in minutes instead of days, reliably and securely. To learn more about 2FIN, the security policy company, go to securityweekly.com/2FIN and sign up for a free evaluation. By the end of 2020, 99% of exploited vulnerabilities will be publicly disclosed and known to IT system admins. The consequences of that fact means the burglar will already be in your house because you left the front door wide open by failing to patch known vulnerabilities. How can you keep the threat actors out? Through cloud-based automation, Automox enables you to slam the door on unpatched OS and third-party vulnerabilities across your entire Windows, Mac, and Linux infrastructure. Take advantage of a free trial with Automox to not only see the vulnerability status of your infrastructure, but do something about it within minutes. Start automating the fundamentals of cyber hygiene at securityweekly.com/Automox. That's securityweekly.com/Automox. Welcome back, everyone, to Enterprise Security Weekly. Security Weekly is returning to Las Vegas for Black Hat and DEF CON. We will be conducting interviews and doing live shows from Black Hat with sponsorship opportunities. You can go to securityweekly.com/booking to do that. Book some briefings, book sponsored interviews, which are really pretty close to being sold out. So make sure you do that soon. Two left. Awesome. I'd like to welcome Adam Gordon from ITProTV. Adam, welcome to the show.
Hey, how's everybody doing?
It's good. It's nice to have you back on the show here at Security Weekly. And today we're talking about container services now is it Azure or Azure?
It's your preference, whichever you would like.
I kind of sometimes I like use both in the same conversation. Yeah. So just a fair warning. But Microsoft, so where I saw this actually was, I think it was inside like VS Code, you can link to containers. And since VS Code, right, obviously Microsoft product, Azure, obviously a Microsoft product, there was like great documentation. I'm like, that could be a really cool place to put all my containers, right? Because who wants to host containers on your own? I guess some people do, but I think it's much better to host them in one of the cloud services. So Adam's here today to talk about Azure and containers.
Yeah, so I thought it would be actually good to start by talking about the general idea, and more importantly, maybe comparing across two of the major platforms that are out there, because what we see with cloud services is that reality is it's really pretty much an all-you-can-eat menu, right? That's the idea behind cloud services: pay for what you want and consume, and then as a result, get billed. But you also have the ability to go with more than one vendor. And these days, unlike perhaps in the early days of cloud services, well, there was a lot of differentiation. Certain vendors were specializing in certain things, right? We all probably remember Citrix being on the cutting edge of providing not only virtual desktop, but also cloud-based, or what we would think of now as cloud-based application services, farm services for applications. But today, it's a pretty ubiquitous concept. Every cloud vendor provides those kind of services. And when we look across the platforms and we look at container services, we see pretty much the same thing. But what I get from a lot of customers, what I get from a lot of people I interact with is, yeah, I know what it's like in this platform, but I don't really know what it is, or if I'm using it over here, I'm not really sure what it is over there. And so what I thought would be good, and let me just share my desktop while we're getting started here, and then I can throw up this little slide that I have, and I'm going to put it in presenter format just so it's easy for everybody to see. I thought it would be good if maybe we went ahead and just put up a quick comparison between what the container services are on the Microsoft platform on Azure on the left and the equivalent competitive offerings from Amazon over on the right, because these are the two most people are familiar with in one form or another. And the trick with Amazon is you put Elastic in front of everything, and basically that's what you have. But you can see there's a lot of similarity. We have Kubernetes running in both platforms. We have an app service available in both, although it's called Beanstalk on the Amazon side. The container solution is essentially named the same. Batch, and we'll define what all these are in a moment, named the same. Service Fabric is called App Mesh, but essentially it's the same idea in both. And the container registry, where we home our containers and are able to work with them, as you were suggesting when we got started, Paul, are going to be the same in both. And so if we start from the concept of what are the key components of a cloud service specific to containers, we have 6 elements regardless of the platform. And what I thought would be good was to quickly give everybody just a little background, a little bit of vocabulary and some definitions over the next couple of slides. Along the way, we could talk about what the use case or the potentiality of using these services may be, really to give everybody a better understanding of why they might be not only interested in talking about and using container services, but what the value add is at the end of the day for them as a business.
Hey, Adam, before you go there, one quick question from me is there's another service on the Amazon side known as Fargate, which is really kind of a container as a service offering where you just literally drop containers into Fargate with memory CPU requirements and it goes off and running. Is there an equivalent in Azure for that type of Fargate service in Amazon?
So there is. You could go a couple of different ways, but basically all the elements of Fargate, first of all, are on the list that we have on the screen with Azure. But probably the closest thing you would see to it with regards to just put something there, spin it up and off and running, if you will, would be, depending on how you choose to approach what you're developing and how you want it to run, would either be batch, which would allow you to scale across huge workloads, potentially high performance computing, in other words, potentially, and you could scale that massively. But generically, at the base level, the Kubernetes service really is very similar in the respect that it does give you the ability to build either something very complex or very simple, just almost a push button run kind of idea, the way Fargate is, and then to scale it and manage it depending on how you choose to approach it with built-in task solutions, either a command line or graphical interface. Fargate does provide for both as well. And so it's very similar in that respect.
Got it. Thank you.
Yeah, no problem. All right, so that's probably a good place maybe just to jump over. What I did is for the next few slides, just took each of the services and threw up a sentence or two, just as a working model for us to maybe talk about the high-level offering, but also what it means to an average enterprise customer if they're not familiar with any or all of these offerings and what the business case or use case may be.
And Adam, that was by my request, of course, because I think one of the more difficult things is when you start looking into these types of services, whether it's Azure or Google Cloud or AWS, Amazon, is just the language and what they term everything, phrase everything, the names they give to things, and it takes time to be accustomed to the lingo and the dialogue. Which I think if we can cover it here today, right, will kind of help people adopt these technologies, whether it's on the enterprise side or whether, really where I'm going is like most of the applications I write are going into some kind of container early on in the development stage, if not from the start, just so it can be more agile and so I can really host them anywhere, right?
Absolutely. And I only put up the Microsoft-centric services on the left of the prior slide for the definition, but you could mirror these definitions over to the Amazon side. You would just have to change the name, but the concepts and the ideas are the same. They basically are two sides of the same coin. So with regards to Azure Kubernetes, maybe 2 to 3 years ago, right, approximately, Kubernetes was this open source kind of standalone thought process that really Microsoft had not embraced in a meaningful way. Amazon certainly was already embracing it, but Microsoft's a little late to the game, to be fair. Maybe 3 to 4 years ago, let's say, because you started to see it emerge in the Azure platform around 3 to 4 years ago. But really in the last couple of years, especially with the huge push across the entire depth and breadth of the Microsoft stack to embrace open source, Kubernetes has become really a front and center solution for orchestration to deploy, manage, and scale these containers. And it's undergone a revision. This used to be called ACS a couple of years ago. It's now been rebranded AKS in the last 18 months or so, and has really scaled to embrace not only the open source thought process of how we orchestrate, deploy, and manage. So the prototypical DevOps thought process we want to bring to things these days, but also has really added a lot of depth and capabilities from the command line through really the embracing of the concept of one button or push button deployments with JSON-based scripting and automation, and scalability, as we were just talking about, that's massive across the entire service stack. So this really underpins much of what we talk about with container services, because this is how we ultimately could scale and manage the containers once we actually have them in the container registry, and we link them to other services like App, Batch, and the Service Fabric. So this is really the starting point for most of what we want to do with regards to services, at least the container services aspects within the Microsoft platform. I do want to go through all 6, but let me just quickly kind of break out of this for half a second. I'm going to stay on the deck, but let's just talk about how you onboard, right? Because I think a lot of people, while they're probably familiar with cloud services today, I hear from a lot of customers on a regular basis, I wish we would have either understood we could dabble, right? We could try for free before we jumped in, or that we could spin up essentially an isolated, whether we call it an air-gapped or a dev environment, whatever it may be, but a test bed, right? Where we can play with these things, have our individual admins, our DevOps people, whatever it may be, go get their feet wet and really start to understand how to link this back to our world before we go ahead and we throw something out there and we start to build on it without really understanding everything we're doing. And so, to the credit of all the cloud vendors, not just Microsoft, but certainly Amazon and Google as well with GCP, the Google Cloud Platform, all of them are offering great services, great capabilities, but also the ability to really understand before you buy. You can onboard for free and really get anywhere from several hundred to perhaps 1,000 service hours credit, depending on what you're doing, and set up environments that can be used to demonstrate as well as to figure out before you actually commit to production. So I think it's important for everybody to know that this is not something you have to do blindly, but you really have to invest the time to figure out, and you have the tools and necessary resources to do that.
So Adam, if I'm looking to host my application, I need to configure some type of app service in addition to my containers?
Well, you would probably want to have an app service ultimately, because you may want to have that app run across more than one platform and one or more programming languages and in one or more forms. Mm-hmm. So you could set up just the AKS solution, put your container into a container registry, which we'll get to. That's just the holding bin for containers. You could call that solution and spin it up. But really, to have it do anything and to have it scale and really be meaningful, you have to have an app service that's going to allow it to really understand how to interact with the outside world.
Gotcha. Okay.
So the answer would be yes, you want to have an app service linked to that. Mm-hmm. But the idea is you will build those apps, whatever they are, as you can see, based on kind of what I put there, across multiple different, I guess we could say verticals or stacks or different thought processes, however you want to frame that. But I think one of the key really interesting ideas around an app service today is the extensibility in programming languages. .NET, .NET Core, certainly Java, RESTful APIs, Ruby, et cetera. All of these are supported, right, without really having to worry about building the prototypical monolithic architectures we have to build to be able to do the development in those areas.
And does that go for databases too, Adam?
Once you have an app service running, you can scale at workloads that are just massive. Didn't mean to cut you off. Sorry.
No, that's okay. So does that go for databases too? Like I'm using RDS today, right? And there's lots of different options I have for the different databases that I can build and basically host in Amazon's cloud. I'm assuming Microsoft has something similar, but like, can I host MySQL or MariaDB or the various options in Microsoft's Azure as well?
Sure, depending on what you're doing, the native database, kind of the go-to, right, on Microsoft's always been Microsoft SQL. So SQL on Azure is certainly the lead option that most people would talk about, but it's by no means the only one. We do support a variety. There are a variety, I should say, of different options. The tabular data service, one of the data services that's available, allows you to go out. The table data service, when I say tabular, allows you to go out and interact with databases in a variety of forms. And you have, at scale, the ability to be able to run things like Hadoop for big data and to link to massive backend data engines. So yeah, you can pretty much scale into almost any platform you would think of that would be available at the enterprise level today,
Awesome.
really with little to no difficulty. So where was I? Oh, yes. So the thing I just wanted to point out, a lot of people, when we think about containers, and I know we've talked about this before in some of the other podcasts and discussions we've had, a lot of people are Windows-centric or Linux-centric, excuse me, maybe one, maybe both, depending on the enterprise. But we do see support for both, right? Both in the app service and in the container service as well. Docker Swarm and Docker. And a variety of different solutions are available as we think about containers. And all of that is really ubiquitous today. So years ago, when you were saying, oh, but I did all my web hosting in Linux and I can't really port that into a Microsoft world, let's say at the enterprise level, or I'm doing all my development in Windows, but I don't know how to scale that and host that outside of Windows to a Linux-centric solution, excuse me. We really don't see those roadblocks anymore with container services and more broadly with cloud services.
Adam, if your design from day one is multi-cloud, portability of the containers, I'm assuming you're going to tend to go Linux containers because that's more ubiquitous across all three of the cloud platforms versus a Windows container?
I think up until recently, that would have definitely been the case. No argument. I think that because Microsoft has really made this commitment to open source in a variety of areas and that they're really moving everything that they're trying to do in that direction and really level the playing field. SQL, for instance, now, right, can run in Linux. It has been able to run for some time, actually. And when we think about that, the preponderance of enterprise hosting, especially in the web service space, has always been on Linux. But I think you can make the case that I don't even think it really matters in the next couple of years whether you're running Windows or Linux. I think what is the bigger issue for enterprise customers and what they have to think of is which cloud service provider, so is it Microsoft, is it Amazon, is it Google, that I want to commit to based on the services they provide and probably the pricing, although both of those are almost identical across the platforms with minor exceptions, probably at the high end for things like high performance computing. And as a result, I think a lot of those questions really tend to melt into the background and tend to go away because they're not really important to the end user who's consuming services. They have never really been, for the most part. And because now it's so easy to host regardless of what you're running, they're becoming less and less of a decision point for us on the back end. What I think is interesting as a way of thinking about it instead is, and I've been having this conversation a lot with customers, but from this perspective, let's forget about what the platform is for a minute, whether it's Windows-centric or Linux-centric, excuse me. Let's talk about this from two perspectives. One, what are you looking to automate and what services and capabilities exist to do that automation on the platform? Then Windows and Linux does become important if you're a Puppet, a Salt, a Chef, platform user. You want to think about those things versus, some of the other capabilities that exist, right? So that may still drive differentiation. But how about BCDR, right? Business continuity and disaster recovery. We often think when we go to an enterprise cloud solution that we kind of transfer risk and we don't really necessarily have to think about or worry about failover and failure because we're paying a lot of money to that provider to take care of that. But the reality is, we still have to worry about where our apps are running. Do we have that code backed up? Do we have a plan if that service is unavailable because the platform itself were to fail? And I think when we get into technicality like BCDR and whether we're failing into, out, over through the cloud to another provider as part of our recovery or continuity solution, then I think focusing on Windows versus Linux is still really critical because it's important to make sure where you wind up is going to support what you're running. And that's not always the case. So I think there's still definitely reasons to consider it. But I think the cloud vendors have really done a great job of making a lot of those decisions really irrelevant to most of us because you can support almost anything as long as you're smart about how you architect.
Yeah, and I think Microsoft made an announcement a few weeks back about embedding a Linux kernel into the Windows operating system, which would even, I guess, make that a little easier from a decision standpoint if you had Linux kernel support within a Windows OS as well.
And to be clear, it's not just that they're embedding the kernel because we've had a microkernel, a la a containerized solution, if you will, the WSL, the Windows solution for Linux that's running in Windows now for probably close to 2 years, the subsystem for Linux. but it's not a full Linux kernel, right? To be fair and to be clear, what the announcement you're referring to spoke to is the fact they're embedding a fully functional Linux kernel going forward. And that is going to radically change our ability to cross-platform host. And as I suggested, probably move that conversation about platform preference, if not into the background totally, certainly to the margins in most cases for most business use cases, unless we're talking about something really specific and technically challenging that may require an understanding of how to manage one or both of those, as I suggested, maybe through a BCDR or a continuity of operations thought process. But we're seeing it really recede to the background more and more. And I think in the next 2 to 3 years, once that kernel is vetted, really people find it to be useful and that it is stable. It's, the first go around is always a little bumpy. But I think going out of Server 19 into whatever that becomes in the next round, I think you're going to see that that's going to really become almost a non-issue for most of us.
Cool.
There'll always be some diehards, but I think in general, you're going to find less and less resistance to cross-platform hosting just because it's so ubiquitous and so easy. Container instances, right? This is the third major element of what we think of as container services. When we want an isolated container, in other words, the prototypical thought process around needing containers is really what we think of. And these are just the containers we build and that we put in there. But anything from simple applications all the way up to very complex solutions, full container orchestration, service discovery, as I call out, those things get linked back to AKS. And that's why I was suggesting earlier, as we were talking about how does something like Fargate kind of compare back to where we are. It's a couple of different elements that make up that solution. But the reality is you have all the building blocks within what we think of as container services. It's just a matter of putting them together. But as we get more complex and we want more automation, more scalability in the enterprise and across regions, service regions at scale globally, we need to think of taking those container instances and really moving them and hosting them into AKS so we can scale and we can manage it at full load across 5, 6, 7, 10 service regions, whatever that may be.
And Adam, are developers still mostly developing locally and then pushing up into the cloud-hosted container services to basically save cost and do more rapid development? Or I guess that depends where you're doing development, right?
It probably depends, I think. I have a lot of customers that are doing a lot of work strictly in the cloud. I have a lot. I would say it's probably less than 50-50, but it's getting closer that are developing locally. You mentioned, right, I'll bring up your favorite program here if you give me just a second. You mentioned Visual Studio Code, right? And so I have it up on my screen right now. Just I happen to have it running in the background for some stuff I'm doing. Whether it's something like this, which is a free solution, whether it's Visual Studio on the Microsoft side, it's a full-blown IDE, which has free as well as pay solutions, or any other program, not just Microsoft-centric by any means that you're using. I could do all my work here without being connected, or I can connect and develop in real time while I'm connected through a terminal. As you can see at the bottom of the screen, I have PowerShell core running, but I've also got the ability to run Bash and a bunch of terminals here, including linking it out to the cloud. And so as a result, I find more and more, I'm just going to go back to presenter mode while we're talking, that it's today just really doer's choice. I think the only characteristic I tend to hear from customers about this is, the old safety net that we still always have to be very aware of, which is, anything we do in production, if it's not vetted, tends to lead to disaster, right? Because we're developing live.
It's that whole worked on my machine. And as much as you think the environments are ephemeral and shouldn't matter where you run your containers or your environment, I've personally uncovered things where it actually does work on my machine, but when you push it up to the cloud or wherever it gets off my machine, that there's still some things in that DevOps tool chain that can cause it to not work. And so you have to construct that very carefully. And there's a lot of tools involved, regardless of which platform you're using, right?
There are. And you bring up a great point, which is, a lot of times, depending on what OS you're running on your machine, you're developing, you're creating your containers, you're hosting them in your DevOps pipeline, essentially, right? It's being built and managed in an instance that is not going to mirror what you're hosting in production when you go into a cloud service.
Right.
And because of that, and people often forget that, because of that, especially if you're running a client-centric OS as opposed to a server OS as your main desktop, is most people do. Most people aren't running on the Windows side Server 19 and then hosting in Server 19 in the cloud. They're running Windows 10, doing all their work there, and then pushing to Server 19. While the code base is very similar, it's not identical.
Yep.
And while the tool set is similar, there are changes based on what builds you run.
Well, yeah, because one
run
thing
into this as you do all the time.
One thing I'm struggling with, and when I talk to other developers, they're also, at various stages of implementing. So locally, when I do my development, I want to turn on all the debugging. I want to have unit tests, and that makes your containers in your code like a heavier memory footprint, and not as fast. When you push to production, your tool chain should be stripping all that stuff out. So when you're pushing to production, it's just what's needed for production. That in and of itself forces it to really have to go through a full regression test and full testing before you do that. And that's some of the things. Again, I think some people have that down, and I would love to talk to people that do. And there are, people in various stages of doing that. But I think it kind of speaks to some of the differences between, your various environments when you're using containers.
Absolutely. I'll share with you just a quick story from the real world about this. So when the Windows Terminal app that they're about to release and have go live, so you can do a one-button deploy of this, went live initially, all you had was some code. You had to download it from the GitHub repo. And this is the idea of tab terminals in Windows that's become really popular. A lot of people are talking about over the last couple of months. And so when the code went live, I downloaded and built the repo, or downloaded the repo and went to build the code and compile the app and run it. And then we did some shows on it on ITProTV and talked to people about how to use it. And we did the exact thing you're talking about. I had to take the code, build it, and then once we went ahead and we figured it all out and got it ready for prime time, we had to strip out a lot of the debugging and some of the issues that we were dealing with. And as soon as I deployed a brand new OS build, because I do the insider fast ring build, so every week I'm getting a new OS build essentially on Windows. First 3 that we did broke the app. I had to go back and recompile the app and fix all the problems. A lot of it was dependency related for packages, but I had to fix those in Visual Studio before I could redeploy the app to get it working. And it's very, very common. And it's a big issue amplified in the cloud because it goes out so quickly. You don't get feedback until you check it.
Yep.
So it definitely is something to be aware of. There's no doubt about it. As you pointed out, I think there definitely are solutions and people deploying those solutions that can mitigate those issues. But you gotta be on top of your game when you're thinking about how you're building and then deploying in the cloud. You've really got to pay attention to not only dependencies, but the best practice thought processes that DevOps brings to our development pipelines, right? And the idea of understanding how to critically regress, but also critically test, right? To ensure that you understand what's going on at each stage. So batch is, and I happen to think batch is one of the most powerful services we have within the cloud service architecture, and the equivalent, right, on the AWS side as well. But this is where we can scale. We get these pools of compute nodes, and we basically put the app on it, we schedule it, and then we just walk away and it runs. We don't have to worry about clustering, job scheduling, in the sense that we have to install, manage, and own that. Instead, it's all going to be dealt with from the perspective of the platform. We have APIs, whether it's batch APIs or Amazon's equivalent APIs, command line scripts like JSON scripting, for instance, and Azure CLI, whatever you may choose to use, PowerShell today, whatever it is. And we can monitor, manage, and configure all that either strictly from the command line, or we can do that via the portal or any combination. Actually, I don't know if Amazon has the equivalent of this, but on Azure, there's an Azure app. Everybody has an app for everything today. But there's an Azure app you can download and run. I run it on my BlackBerry, on my phone, and I can actually go in and manage Azure instances for customers or whatever I happen to be working on. It's not the most easily usable solution. It's on a phone, the screen is small, the keyboard is clunky. But one of the interesting things I can do is I can actually open up an Azure CLI command line, and I can interact with batch solutions or any command line offering that I want. If I know the commands that I want to type, or I just have something I need to check, I can do it right from my phone or any mobile device today. And this scalability and ease and portability is really what we're paying for in the cloud. And it's becoming more and more, not only commonplace, but so easy not only to deploy, but really to keep an eye on this stuff from the back end, because so much of it is managed by the platform itself once you kick it off. it's kind of interesting in
Cool.
that respect. But batch essentially is this idea of platform as a service at scale, right? So I talk about the fact you could build SaaS applications here as one example. If large scale execution may be required, I thought something like, if you're in financial services, you're familiar with Monte Carlo risk simulations, you could build and run those using a batch solution. You could do massive scale image processing if you have customers uploading images. I'm thinking of, let's say, insurance companies that are dealing with accident claims, right? And have to process images on a regular basis. That's kind of stuff that batch would be used to scale for, if you think about the logic of that as a use case.
Sweet.
And then the last two, it is actually really neat when you think about what you can do with it. And then the last two elements that made up our list were Service Fabric and the Container Registry. I'll jump to the Container Registry just because it's the easiest of all of them, and it is really the thing that binds and wraps everything else we talked about together, because it's the holding pen where all these containers are going to, or these images that we think of as containers, are going to reside. It's a managed Docker registry service. We talked a little bit about interoperability across platforms earlier, Windows versus Linux, and the open source commitment Microsoft has. And the Azure Container Registry is essentially a Docker registry that's running windowized, if you will, running in the Azure stack. And it allows us to put all of our container images there. And then as a result, we're able to integrate with our build and our deployment pipelines. And we do all sorts of stuff today because of the integration with Git as well. In GitHub, you've got a tremendous scalable enterprise platform that is able to not only host code, but then bring it to bear and deploy it with usually just a couple of clicks of the mouse. The running of a JSON script is pretty ubiquitous today. That's what we use primarily. But as I suggested, I could do this off my phone with an app and a command line from anywhere in the world. If I'm sitting on a plane, I have wireless access. I can deploy infrastructure for customers.
The way our in many people's DevOps tool chains work is once you push into a specific branch, Jenkins can automatically get notified that that happens and build a release and put it in the registry and deploy it. I'm assuming all that's possible in Azure.
Absolutely, and with the standard tool sets like Jenkins that you would think of, it's not just Jenkins, but there's support for all of the things we would think of today that are running and that most of you that are listening are familiar with, that you might not think of as being a Microsoft-centric solution 2, 3, 4 years ago, but because of this broadening of the platform are open and available. The Azure DevOps solution has really undergone a massive, not only I think enlightenment with regards to thinking about how DevOps can be handled and then the link to open source, but it's really become, and over the last year especially, it's been pushed to be front and center as part of the offering thought process to attract enterprise customers, to get them to see that all the things that we need to do and have been doing, but in many respects have probably been doing outside the platform, are front and center and available in Azure. I think to Amazon's credit, they've done a lot of that, did it sooner than Microsoft did, and so they got out ahead of it. I think Google's playing catch up in the GCP space, but they're also coming to the realization that they have to be an enterprise service if they want to be able to really attract and sustain corporate customers on the cloud side. And they're transitioning from a consumer service into an enterprise offering, and they're doing it as well. And so we're seeing, you have two really heavy duty, and if you include Google as an up and comer, 3 globally scaled cloud offerings that if you strip away the name and some of the off in the corner differences, as I suggested, pricing and maybe some high-end use cases, it's like buying a pair of jeans today. 30, 40 years ago, you bought a brand because you wanted that brand and there might have been a quality difference. Today, it's a pair of jeans, wherever it's made in the world, notwithstanding your predilection for service, a specific name on the back of that jean, notwithstanding. It's a piece of fabric that anybody can create and anybody can make and essentially do. It does the same things. And cloud services are really becoming that, and containers are just one element of that. And we have the service fabric. This is the thing that allows us to be able to have microservices. These are one of the big buzzwords of cloud services and containers today. But these microservices running at very high density and scale, again, in these pools of virtual machines that we call clusters. And we have the ability to be able to scale and deploy these runtimes almost immediately, very, very small deployment times and very, very quick scale up and scale out times. What people also overlook with things like Service Fabric is the ability, and you could see I talked about the ability to do provisioning, deployment monitoring, upgrade patching, et cetera. And containers are obviously fully supported there. But I talked about scale up and scale out. What people often forget, and is one of the key value propositions for the enterprise in a container space with cloud services, is the ability to scale down and scale in. When we lose that need for burstable solutions that are scaling to meet demand, you don't want to pay thousands of dollars in overage charges a month for services that are being underutilized. That's the dark side of cloud services we sometimes overlook. And all of these services today are capable of scaling up and out massively, but also scaling in and down quickly if, because of the automation and the monitoring provided by the platform provider, if you bring those to bear, we can have scale sets that will scale up on demand, but then scale down. So you're not paying for consumption that's not there, which I think is a very important proviso around container services.
Yeah, I like that. I think there's a lot of security professionals that may have, software utilities that they've built that could benefit from that. You think about password cracking or analyzing logs, right? Those are things that could scale up, use compute when they need it, and then scale back down.
The other thing I like about this is putting workloads close to consumers, right? Think about a global company that as the sun moves, their user base may be shifting, and the ability to move workloads around the world to get them closer to where the users are to improve things like performance and latency, et cetera, that all gets supported in these microservice architectures too.
They do, and it's a great point to make. Let me just throw a caveat out there for everybody. That's the sexy, cool part, right, of cloud services, and container services as a part of that. And we hear a lot about microservices. The last year or two, especially, they've become very, very popular as one of the key selling points for cloud based on what you just described. But what I think we have to be wary of, and what people often miss with that, right, is let's go back to kind of 101, the basics, which is, global architecture requires global planning. And you divide into regional zones and service zones based on the provider's specifics. But all the providers essentially scale these services, at least the ones that are generally available. They scale them across their service zones globally. You have your SLAs, you do all the stuff you have to do. But if you're not managing demand, to your point, and you're not using the automation services that are available to manage demand, you're going to be overburdening one region that's probably really being tasked with servicing multiple smaller geographies. And that's not an economy of scale. It's actually, unfortunately, going to cost you more money than you're going to wind up wanting to spend as a provider of whatever the services that you're serving up. And I have to talk to customers about this all the time, because the trick with really leveraging this ubiquitous, globally scalable cloud platform, whoever provides it, is the ability to not anticipate service and need, because it's hard to do that at a certain level, but it's to be able to react once that need and service makes itself apparent wherever it is on the globe. And so the ability to scale through regional failover and support through these things, like whether it is a what's the term I'm looking for? I can't remember the term right now that we use, but ultimately the idea of having these availability zones was what I was trying to think of. I just couldn't remember what it was called in Microsoft. I kept having the Amazon version of that pop into my head. Using this idea of availability zones and this idea to quickly react and scale across the geography is crucial to success, because you can serve a container up, as we talked about, from anywhere, but if all your traffic has to come across from a different region to get to it, even though the delay may be slow and the impact may be minimal, you're going to ultimately see that trailing out across hundreds, thousands, perhaps tens or hundreds of thousands or millions of engagements with that service. And it's going to become a problem for you. And you're going to spend a lot more money dealing with that if you're not smart about it. So it is important to call that out, but it's important to think about how you stop those solutions to make them scalable and elastic. It's very, very important.
Awesome. Well, Adam, thank you so much for sharing all of the knowledge and information in this segment. I know ITProTV has some training specifically on this topic that I think you just updated recently, correct?
We do. We actually have the full Amazon certification stack on AWS available, been updated to reflect their most recent offerings. And we have the Azure stack as well, updating in progress as we speak to reflect the newest Microsoft certification offerings, both for Azure and also O365, the Office 365 cloud solution.
Awesome. And you can find more about ITProTV at some website that I believe is securityweekly.com/ITProTV. How about that? You can go there.
Go. That works. You could just also go to ITPro.tv. Either one will work.
Fantastic. Adam, thank you so much.
Thank you.
With that, we will take a short break, come back, and talk about some of the lingo that's used in mergers, acquisitions, and funding rounds. Stay tuned.